and then simplify. So here got 1 square minus the square of the root of 3, so it's the 1 minus 3. And then the numerator, we can use the square of the binomial formula, that is 1 square minus 2 times 1 times root of 3, and then plus the square of the root of 3, that is 3. Now let's continue to simplify. So you have the 1 plus 3, 4, minus 2 times root of 3, and divided by -2, right? So now you divide each term of the numerator by -2. You divide this guy by -2, you have the root of 3. You divide this 4 by -2, you have the -2. Here I switch these two terms. I put this first and put this second. So finally, you have the root of 3 minus 2, and this is the value of the tangent of the -13 pi over 12. Tricky? A little bit, right? So first, when you have an angle which is kind of big, you can first simplify by throwing away the multiple, some multiple of the period. So right now this guy, up to a sine, this 13 pi over 12 is bigger than pi. So we can throw away one multiple of this pi and then simplify. Then you have the tangent of the negative pi over 12. And here I use the property that the tangent is an odd function. Actually, you may also write this as the 3 pi over 12 minus the 4 pi over 12, right? And then you can still use this tangent of a difference identity to get the same value. Now let's look at the 67. Some guys asked me about this problem before. So find the exact value of the sine of the alpha minus beta if we know the sine alpha and we know the cosine beta, and we'll also know the position of this alpha and beta. So alpha is in the quadrant 3 and beta is in the quadrant 2. Now let's first list the knowns of this problem in the whiteboard. So this is the page 535, problem 67. We have the sine alpha equal to -24 over the 25. And we also know cosine beta equal to -8 over 17. Alpha is in the quadrant 3 and beta is in the quadrant 2. So right now we need to find sine of the alpha minus beta. And we know the sign of a difference identity, so this guy is equal to sine alpha times cosine beta minus cosine alpha times sine beta. So right now in this expression, we know this sine alpha, right? And we also know this cosine beta. Then we need to find cosine alpha and the sine beta. So now let's use the fundamental identity to find these two function value. So first, let's find the cosine alpha. Since alpha is in the quadrant 3, so cosine alpha is negative, right? So cosine alpha is equal to negative square root of 1 minus sine square alpha. Then let's plug in the values into this expression. Negative square root of the 1 minus negative 24 over 25 and the square. And you can use a calculator to compute this. So you got the negative 7 over 25. And we can also find the sine beta. So beta is in the quadrant 2, so sine beta is positive. So sine beta is equal to the positive square root of 1 minus cosine square beta. So this guy is equal to the square root of 1 minus the square of negative 8 over 17. And you can simplify, okay, using a calculator. Then you can get 15 over 17. So now let's plug in all these values into this expression for sine of the alpha minus beta. Then we can get sine of the alpha minus beta equal to, okay, first the sine alpha, which is the negative 24 over 25. And then cosine beta, which is equal to negative 8 over 17. And then minus cosine alpha, which is equal to negative 7 over 25. And then sine beta, which is equal to 15 over 17. Then you simplify, you get negative 87 over 425. Done. Now let's look at the page 536. We try to prove this problem 92. Okay, prove this is an identity. So let me copy this problem on the whiteboard. Page 536. Problem 92. Cosine of alpha minus beta over sine of alpha plus beta equal to 1 plus tangent alpha times tangent beta over tangent alpha plus tangent beta. Okay. And let's begin with the left side. Since this is cosine of a difference and a sine of a sum, right? So we can use the cosine of a difference and sine of a sum identities. So the left side L. This numerator cosine of the alpha minus beta is equal to cosine alpha times cosine beta plus sine alpha times sine beta. The denominator sine of alpha plus beta is equal to sine alpha times cosine beta plus cosine alpha times sine beta. Now we can divide both the numerator and denominator by cosine alpha times cosine beta so that we can get some tangent alpha and tangent beta. So right now, let's divide this numerator and also the denominator by cosine alpha times cosine beta. So now, let's divide each term by this cosine alpha times cosine beta. So this guy, you have the cosine alpha, cosine beta over this cosine alpha, cosine beta. And then sine alpha sine beta over cosine alpha cosine beta. And then the denominator, the first term divided by cosine alpha cosine beta, you have the sine alpha cosine beta over cosine alpha cosine beta, and plus cosine alpha sine beta over the cosine alpha times cosine beta. Now you can simplify